All right, today we'll be talking about 8.3's polar coordinates. So very similar to uh, plotting points on a plane. So when we did plot points on a plane, we usually thought about x and y. So x is the vertical, I'm sorry, horizontal, y is a vertical. And that's called the Cartesian plane, which is just a two-dimensional plane for x and y, right? Let's think of a sheet of paper. I'm plotting points on the paper. Okay, also called the xy plane. In this section, though, we're going to do polar coordinates. So still two-dimensional on a plane, but we're going to use radius and theta. So r and theta, radius and angle. So we're going to plot those on a polar grid. Now, the way to do this is first find the angle in question, use the theta first, and then go out whatever r is. So in this case, example one, it says go to pi over 2, then go out 3. Okay. So all you have to do is remember your unit circle, right? Pi over 2 is 90 degrees. So pi over 2 is up here. So you would go out over here and go out 1, 2, 3. So this is 3 comma pi over 2. So the distance and the angle. So that's how you do a polar. Now visually, let me show you the book. They have a better picture. Right here, you can see the example 3 comma pi over 2. This is called the polar grid right here. So you sweep to that angle in question, pi over 2, which is 90. So I go over there and then I go out 3. So go 1, 2, 3. Now there's many ways to represent an angle, which means there's multiple ways to represent this particular point. Okay, so let's do another one. This time it's negative. Example 2, plot the point -2 comma pi over 6. So go to this angle first, which is pi over 6. That's going to be 30 degrees. And then go back to. Okay. Well, so here's 0. So pi over 6 is about right here, right? Kind of. Now go back 2. So 1, 2. So my point would be here. Okay. Because it's a -2. So now look at the picture, and they have a better picture than I do. Pi over 6 is -2, so you go to pi over 6, right? And then you go -1, 2. So they have like little radii circles here for their grid. So 1, 2. You can go to pi over 6, which is right there. We'll go backwards. Okay. In this question, they said just plot it. Here they're trying to show us that you can technically find that same point multiple ways, right? Actually, no, they don't. But if they did, you could just say, you know what, I'm going to go to this specific angle and then go out to, instead of going over here and then going back to. For example, this one's easy to see. I could have said this angle here is the same as, let's see here, -3, comma 3 pi over 2. So I can come down here, then go back 1, 2, 3, and still land at the same spot. So these 2 points would be the same location. But anyway, let's move on to something else. So that's how you graph negative angles and positive angles. All right, let's do another example. So we're going to need these formulas for the next few problems. There you go. Remember, let's go over them real quick. Remember that cosine theta in general is equal to x over r, where r is the radius of the circle in question. If the radius is the unit circle, well, that's 1, so that's what's always the x value. If it is not a unit circle, it's some rando circle, then you have to use a different radius, which means you can solve for x and transform it. So you can change an x value into polar. So if you have like a x and y point on your graph, you can change to a polar version of it. Okay, so you can always go from r sine to y or r cosine to x. R squared is equal to x squared plus y squared. And of course, you can solve for r, the radius. So if you need the radius, you can just square these guys in square root. Tangent is y over x. Theta would be tan inverse of y over x. So you can solve for theta here. Okay, so let's go ahead and do this first example here. All right, so let's write the polar coordinates 3 comma pi over 2 as rectangular coordinates. So remember, r is the first part, 3. This is r of theta. The angle, pi over 2. So they want us to change it to x and y. That means we got to use the formula. X is equal to r cosine, which will be 3 times cosine of pi over 2, which is 3 times 0. Right? Let me skip this up here. Y would be equal to r sine theta, which is 3 sine pi over 2. Sine of pi over 2 is 1. 3 times 1 is 3. Okay. So that means that the point 3 comma pi over 2 r theta can be changed into 0 comma 3 x comma y. So now if you plot this, you will see it's the same location. It's just represented differently. And check this out. Look at the PDF of the example, where you can see that if I graph it in polar, I go to pi over 2, like we did example 1, and then the 3, you'd be right there. As you go up to pi over 2, and you go up 3. 1, 2, 3. If you plot x and y, well, 0x, y3, same place. So this is the Cartesian plane, or x and y coordinates, and this is the polar grid. So you can convert this to Cartesian or use the polar. And let's do another one. And so example 4 says write the polar coordinates the -2, 0 as rectangular coordinates. So this is still r theta, just a 0 angle, right? Okay, so r is -2, theta is 0. So again, to get x, we got to use x equal to r cosine, which would be -2 cosine 0, which would be -2 times 1. Y is equal to r sine theta, which is equal to -2 sine of 0, which is -2 times 0. So in this case, it turns out to be exactly the same. Interesting. The only difference is this is an x and y point, and this is a angle. So -2, 0 as r theta is the same as -2 comma 0 x comma y. So these are points. This is a radius and angle. these are different. Okay, now let's go the other direction. Let's convert this Cartesian or rectangular 3 comma 3 into polar coordinates. So x is equal to 3, y is equal to 3. Remember that r is equal to the square root of x squared plus y squared, which would give us r equal, which would give us the square root of 3 squared plus 3 squared, which is square root of 18. So r would be 3 square root 2 once you reduce it. So now we need theta in order to convert this. So we got the r. Now find theta. So remember we said theta is equal to tangent inverse of y over x, which is tan inverse of 3 over 3. That would give us 3 over 3, that would be 1 pi over 4. So the point 3 comma 3 is equal to 3 root 2 comma pi over 4. So you got to use the r formula to find the radius. Then you need to use the theta formula to find the angle, and that's it. You got xy going to r theta. In the next example, we're going to convert equations in rectangular, x and y, into polar equations. So we're no longer just changing a point, we're changing an entire equation. So we need to get all the x's and y's into r's and thetas. That's what we got to do. So note that x is still equal to r cosine, y is still equal to r sine. So plug that in here. If I want to convert this, you get r cosine squared plus r sine squared equal to 9. So this would become r squared cosine squared plus r squared sine squared equal to 9. So here I substituted the x for r cosine and the y for r sine. Just substitute. Square both parts gives me r squared cosine squared, r squared sine squared. At this point, you can factor and use some identities to help us out. Identities finally coming in handy here. So cosine squared plus sine squared is going to be 1. So r is equal to plus or minus square root of 3. So it seems, sorry. That our equation x squared plus y squared equal to 9 is the same as r equal to 3 or r equal to -3. Either way, it's going to generate the same graph. It's going to be a circle. You should have noticed, right? This is a circle equation. This is a circle equation 2 with radius 3. When there's no theta, theta can be everything, which means it's going out to all of the angles. And but at 3. So if we graph this, let's go do a graph. So let's say we do x squared plus y squared equal to 9, right? No, that's a circle, or we should. R equal to 3 is the same type of circle. So imagine, since there's no angle, theta can be everything. So basically, for all thetas, right, going around the circle, r is 3. So if r is 3 for all angles, we are drawing a circle. Kind of like when we would do horizontal lines, right? Back in the day. Y equal to 3. If there's no x, then x is everything, and y is stuck at 3. So it creates this solid line here. Vice versa, x equal to 3 would be any y, but x is always 3 for all those y's, which creates this vertical line. That's the same thing happening here. I have a radius for all angles. So basically, if you were to create like a little table, r theta, right? R is 3 no matter what. So as you go around the circle, when it's 0 or 90 degrees or 180, still 3. So as I keep choosing these angles, it's going to create that graph. 1, 2, 3, 1, 2, 3. Anyway, but that's how you convert from this equation to polar. Let's do another one. All right, this time, let's convert x squared plus y squared equal to 6y. So it's not a circle equation. I think it's probably a cardioid or something. But anyway, they want us to convert. That's what they're asking. They didn't tell us, they didn't ask for what kind of graph. So remember, x is our cosine, y is our sine. And we'll probably need this guy too. So just write them again. So I have them. So x squared plus y squared equals 6y. Replace the x with our cosine. Replace the y with our sine. So that'll give me r squared cosine squared plus r squared sine squared equal to 6r sine theta. So factor the r. We have the same scenario as last time. So that becomes r squared times the 1 equal to 6r sine. We have an extra r. Because we end up here. Right? So again, we'll divide this out. Divide both sides by r, we'll get to here. Okay. So this can represent this original. So we converted x squared plus y squared is 6y into r equals 6 sine theta. All right, let's do another one. This one's a little harder. Change y equals 3x plus 2 into a polar equation. So y equal to 3x plus 2, you would change the y into r sine theta equal to 3 times r cosine theta plus 2. So the goal is to try to solve for r. So you have an equation that's what r equals to, like kind of like how we had here, y equals. So solve for that variable. Let's try. So I'm going to move everything with an r to the left. Leave that 2 over here. So I subtracted this to the left-hand side. Factor r from both terms. Now in the next step, we can divide both sides by so let's go over it again. We substituted the y for r sine, the x for r cosine, subtracted this term to the left-hand side, factor the r from both terms. Once that's factored, we divided this out on both sides, which will leave us with r equal to this. So this is the polar equation solved for r. Technically, this is already converted on the first line, but they're going to want us to solve for r in the homework. Let's do one that's kind of like this, starting here and going backwards. Okay, so we write a polar equation r equal to 3 over 1 minus 2 cosine as a Cartesian equation. So right now, it looks like garbage. Let's see here. Remember that x is equal to r cosine theta, right? But that also means that r is equal to x over cosine. So actually, no, that's not helpful. We can use the original equation earlier. On the equation page, we said that cosine is equal to x over r, right? So this would be Let's go ahead and multiply both sides by this denominator, because right now I don't want to deal with a fraction. So let's cancel the fraction first. Multiply both sides by 1 minus 2 cosine. 3 times 1 minus 2 cosine. So then we'll cancel this fraction, leaving me here. No more fractions. So right here, we can replace the cosine with 1 minus 2 times x over r. So I'm trying to get back to x. You know what? Now that's kind of weird too. I got a better idea. What we're gonna do, that's how the book wants to do it, but I don't think that's the easiest way. This is what we're gonna do. We're gonna distribute the r on both parts, getting me to here. And then we can use this fact that this is x to get r minus 2x equal to 3. And then remember that r is also equal to r squared is equal to x squared plus y squared. Which means that this r is equal to the square root of x squared plus y squared using our formulas that we wrote down earlier. So now we don't have any more r's and thetas. So we can make it a little prettier. We can solve for y, move that stuff over, but technically this is done. But if you wanted to solve for y, I don't know, they may ask for it. Let's go ahead and do it. So it'll be 3 plus 2x. If I square both sides, it'll cancel this nonsense. Okay. Sorry. So what we're doing, we start from the top, right? First, we cancel the fractions, got to here. Distribute the r. R times 1 is r. R times 2 cosine is 2r cosine. R cosine is x, so I went back to x. R is equal to this from the formulas. At this point, we're like, okay, we're technically done, but we want to solve for y. So I moved the 2x over and squared both sides, and here we are. So now we have 9 plus 12x plus 4x squared. Once you FOIL this out, multiply it out. Solve for y, this would be 3x, let me show the work. If I subtract the x squared over, right? So this 4 is right here. Subtract this one there. That gives me 3x squared plus 12x plus 9. So y is equal to the square root of 3x squared plus 12x plus 9. Plus or minus. This is one of the harder ones, but just remember your formulas and you'll be okay. And remember, stuff like double angle, etc., might still be in play. I think there's one in there. Yeah, if you see like a sine 2 theta or cosine 2 theta, don't forget your double angle formulas. Okay, so we'll stop here.